Okay, so last week we talked about the slope of a line and counting points, rise over run, or if you were given two ordered pairs, then you use the slope formula. Today we're going to talk about the x and y intercepts, or the point where a line crosses each axis. The point at which a line intersects the x-axis, of course, is called the x-intercept. So in this graph, this point right here would be the x-intercept. That's where it crosses the x-axis at. The point at which a line crosses the y-axis is the y-intercept, which would be this number right here. So the x-intercept right here, where it crosses the x-axis, would be at positive 1, 2, 3, 4, 5, 6, 7, 8. So the x-intercept would be at 8. And the y-intercept, 1, 2, 3, 4, 5, 6, 7, 8 would also be at 8 for this particular graph. Okay, so if you're given a graph, all you have to do is visually look to see where the line crosses the x-axis, that would be the x-intercept. Visually look to see where it crosses the y-axis, and that would be the y-intercept. Now you can also find these intercepts algebraically. If you're given an equation, if you want to find the x-intercept, substitute 0 in for y in the equation. If you're given an equation, and I'll show you what that looks like in just a second, substitute 0 in for y, and then solve the equation that you have left. If you want to find the y-intercept of an equation, you're going to substitute 0 in for x, and then solve for y. I'll show you what I mean. So if this is the equation here, y equals 3x plus 6, to find the x-intercept, the instructions are to substitute a 0 in for y and then solve. So here's my y. So where y is at, I'm going to replace that with 0. So this becomes 0 equals 3x plus 6. I've just replaced the y with 0. Now if I solve this equation for x, I'm going to be able to tell what the x value is, which will be my x-intercept. Two-step equation, I'm going to take away 6 from both sides. So I've got negative 6 equals 3x. And then when I divide both sides by 3, I get x equals negative 2. This is my x-intercept. So my x-intercept is negative 2. So if I was to graph it, it would cross the x-axis at negative 2. To find the y-intercept, I'm going to repeat this process, but this time I'm going to substitute a 0 in for x. So in this equation, wherever I see x, I'm going to substitute it in. I'm going to substitute in a 0 for it. So instead of y equals 3x plus 6, I have y equals 3 times 0 plus 6. Well, 3 times 0 is just 0, and 0 plus 6 is 6. So my y-intercept in this problem is 6. So if I was to graph this, it would cross the x-axis at negative 2 and the y-axis at 6. Maybe I will graph that. Let's take a look and see what that graph would look like. It would cross the x-axis at negative 2 and the y-axis at 6. Crossing the x-axis at negative 2, right there, and the y-axis at positive 6, right there. And then I can simply connect these points, and that's the line that would be produced from that equation by finding the x-intercept where it crosses the x-axis and finding the y-intercept where it crosses the y-axis, and just connect the points with your line. So let's go through some equations here, some examples. So let's look at number 2. Number 2, so if I want to find the x-intercept, I'm going to substitute 0 in for y. So this becomes 0 equals 1/2 x minus 8. And I have to be able to solve this. I can go ahead and move the 8 to the other side. I'm trying to get x by itself, remember? So I add 8, and I add 8, and that gives me 8 equals 1/2 x. And remember how to kill the fraction? Multiply by the denominator. So when I multiply here by 2, I have to multiply here by 2, but what happens, the fraction's gone, they cancel out, and I'm left with 16 equals x. This is my x-intercept. My y-intercept, I'm going to go back and I'm going to substitute 0 in for x. So y equals 1/2 times 0 minus 8. 0 times anything is just 0. So this is 0 take away 8, and 0 take away 8 is negative 8. So my y-intercept is negative 8. Okay? X and y-intercept. So if I wanted to graph them, I would go to the x-axis at 16, the y-axis at negative 8, like I did up here, and just connect the points. Let's see what we got. Let's look at number 5. To find the x-intercept, I'm going to plug a 0 in for y. And solve what I have left over. 2 times 0 is just 0. So really this just goes away. 3x minus 0 is just 3x. Because 2 times 0 is 0. Divide by 3, and you get an x-intercept of 4. To find the y-intercept, I'm going to plug a 0 in for x. And then just solve. Well, 3 times 0 is 0, so that really just goes away, and I'm left with just negative 2y equals 12. When I divide both sides by negative 2, I get y equals negative 6, which is my y-intercept. Okay, so one more problem. Let's look at number 9. So now the directions are find the x and y-intercept of each equation and then graph it. So I'm doing the same thing I was doing up here, but then at the end I'm going to take my information and I'm going to translate it to the graph. So I'm plugging zeros in. So number 9, to find the x-intercept, I plug a 0 in for y. So this becomes 9x minus 15 times 0 equals 45. I hope that you see something that's going on here. When you plug a 0 in, that term ends up going away because negative 15 times 0 is 0. And I'm left with just 9x equals 45 because negative 15 times 0 is 0, so that goes away. Dividing both sides by 9, you get x equals 5. So my x-intercept is at 5. 1, 2, 3, 4, positive 5. To find the y-intercept, I'm going to go back and repeat that process, but now I'm going to plug a 0 in for x. So 9 times 0 minus 15y equals 45. Well, 9 times 0 is 0, so that goes away. And I'm just left with negative 15y equals 45. And when you divide both sides by negative 15, you get y equals negative 3. So on the y-axis, I'm going to be at negative 3. Negative 1, negative 2, negative 3. And then from there, I can simply connect them. And there is the line of that equation using the two intercepts. Okay? So intercepts, think zeros. We got to plug zeros in to find the intercepts. That is assignment 17.